Hello everybody and welcome to my channel. In this video I want to show you everything that's new in SwiftUI. I've spent the whole week of WWDC looking through the div of the API of SwiftUI, looking at all the sessions, including the ones that doesn't seem related to SwiftUI, but they drop some nice APIs in there. So I've collected everything in a nice document to go through it with you. I've also made this project, New SwiftUI, that you can find on GitHub. And if you find something else that I have missed, please make sure to make a PR and we will add it into the example so everybody can benefit from it. There has been a lot of new things added, so this is gonna take a little bit of time. I recommend you that if you want to pause and come back another day, feel free to do it. Maybe I break this down in different parts, but I think that's gonna be a little more confusing, so I don't know what I'm gonna do yet. The important thing is that you take a look at everything that is new. We're not gonna go super deep, so I'm not gonna expecting to spend a lot of time on each piece, but this is so you have a jumping point to then, once you know the new API that you're interested in, you can go and search on blogs, on other videos. Like, the community is making so much content these days that I'm pretty sure that you're gonna find what you're looking for. It's important to note that this is recorded at the end of WWDC, so this is using beta 1, so not everything may be out yet, some things may not work as expected, so probably a lot of things will change during the summer. But still, I think this is a useful opportunity to see everything that is new. So here we are in this project that I created where I have a lot of examples that you can check out. I've broken it down on different sections like new views, frameworks integration, layouts that we have now, the new modifiers, the new property wrappers, and some other random stuff. But to start with, let's talk about the big new thing this year, which is when you go and you make a new project, you have a new multi-platform section that it's gonna let you just create a application with SwiftUI already working on iOS and macOS, so you can start working on a multi-platform project out of the gate. This new project structure also uses the new API from SwiftUI to make a full application purely with SwiftUI. You don't have to use the app delegate or the storyboards anymore. The way this works is that we have this new app protocol that you just make a struct that conforms to it, and you declare this struct with main, which is a new addition into Swift that it's not only for SwiftUI, like there is a lot of applications for this, and I'm gonna have a video about it on my following Swift evolution proposals list. We're gonna go back into this code later, but for now I just want you to focus on the API. Like, you just make a scene, and then this scene can include different window groups, document-based applications, all what we are expecting from making applications on UIKit or AppKit. Now we have it directly available with the SwiftUI API that basically resembles a lot what you do with just views. So now you have views, scenes, and applications, all of it following this declarative API that we are so used to with SwiftUI. As I said, we're gonna come back here later, but for now I just want to show you an example of the new things that Xcode integration brings to SwiftUI. As you can see, we have this new preview menu here that has the same functionality as before. You can still play the preview in case to make it basically interactive, and now it's very nice because you have this green or red status indicator to show you when things break. But now the addition is that when there is no, like, if we can get rid of this, for example, you're gonna see how it tells us there is no preview, and we have a nice button to create a preview directly. It would be nice if it would put here the view, at least if there is one view, but we can just finish that ourselves. One thing to note is that the preview system hasn't changed that much. If you still change the data structure of your code, the preview is gonna stop and you need to resume it. That hasn't changed. I think it's not a big deal, but it would be having nice if they automatically restarted things some now and then. The new additions that we have is a lot of more inspectors. You can see here that we have this inspector. This is to tweak the preview itself. We can change in which device is running from this list of devices, or we can use those different layouts that we already had access before with device, a fixed size, or just the size that fits, which I usually prefer to use the size that fits. It makes it nicer on the preview. But now we have all of it here. we can change the accessibility settings, we can add paddings, frames, or even add any modifier. And this add modifier list, it's actually accessible on the views themselves. We used to have this menu before, but now if you do Control Option click, you have this new inspector on the view itself that allows you, it knows which view you're accessing, so it offers the parameters from the view themselves here, but you also can change more things like the generic padding that it's on every view, or the frame, or you can look for background, for example, and you have all the modifiers that are on SwiftUI here. So that's very nice. It makes it way easier to explore what's going on. But not only that, we also have a new inspector on the right sidebar of Xcode. So you have the same things, but without having to click on the specific code here. And the inspector changes when you click on a view on code. You can see how it keeps updating, but also if you click on a view on the preview, it updates the inspector and it also selects the corresponding view on your code. Everything is super integrated. I just keep thinking about how we used to do things with a storyboard or interface builder before. Now this is such a much better experience where you have your UI and your code, you can play with one or the other and you can just work together. Also, of course, you can use the same command here to access the same inspector directly from the views. The other button that we have here is a button to duplicate the preview, which is super nice when you have a preview that has some settings already. For example, if you have the scheme, let's put it in dark and let's put it like with bigger sizes. So you can just duplicate this preview and you can see that it automatically puts it in a group and it expands to include the other preview. And now you can come here and say, okay, so this one, I want it in light mode. And it's super easy now to create new previews and tweak them and make sure that you cover all the cases that you want your UI to cover. One of the other pain points that they've solved is that on the previous version of Xcode, you were not able to debug the previews. So once you were starting adding some interaction and you wanted to debug that interaction, you just had to run it on a simulator. Now, if we keep clicking here, we can see how, apart from doing the live preview, which is what it happens when you just click on the button, we can debug the preview, and that's going to start the live preview, attach a debugger from Xcode, and we're going to have just access to the debugging session like if it was from a simulator or a device. Another nice thing that Xcode includes is a much better autocompletion. Now, in theory, the suggested modifiers are more appropriate for the types that we're working with. But especially what is very nice is that when you select, for example, padding, you can see that it doesn't just give us the empty modifier, it actually adds suggestions to the values, and you can just leave them there and that's actually a valid. It's not like before that the modifiers kind of like broke your code. That doesn't play very nice with the previews because you're going to be breaking the previews constantly. Now, when you accept one of these autocomplete suggestions, they come with valid values that the interface understands, and so your UI doesn't stop refreshing continuously. And you can just click enter to accept that value, or of course change it to whatever you want, and that ends up being a valid value. Keep in mind that there are some hidden comments that Xcode hides, but the comments are there, so if you don't accept these values, you're going to see weird comments on your Git diff. And you can see that these better suggestions also apply to the inspector that shows you the recommended things that people uses a lot, I guess, or like I don't know what heuristics they use for this, but in theory it should speed up the finding of the modifiers that you want to use. Another thing that I want to show you is how the improvements on Swift itself have made a lot nicer the DSL and the way you work with SwiftUI. For this, let's just add a button here that accesses this state variable. And as you can see, we don't require self. This is a small addition, but one that in SwiftUI it's huge. And if you want to know more about it, I have a specific video about that Swift evolution proposal that was accepted and implemented for Swift 5.3. Another thing to mention about the previews is that now you can run the previews on device with this button. This button is enabled when there is a device connected, and you can literally run this preview on your physical device. You can even do it to different devices at the same time, and they are gonna be updated live at the same time with their own environment preferences. So you can see your UI in a real device and context with multiple of them at the same time, and it makes it so much nicer and quicker to iterate and see how everything is behaving on multiple devices. I can already see people like with so many devices connected and seeing all the UIs updated at the same time. That's gonna be huge for productivity. One last thing worth mentioning about the Xcode integration is that now you can add your own views into the Xcode library. You can add your views here and your modifiers that are gonna show up here. This is super nice. It even works with third-party packages with Swift Package Manager. You can create fully packages that only give you UI. That's now super nice, plus with integration with the resources and localizations. Now you can actually make package libraries that are for UI, and they are very nice. The way you do this is, again, everything feels super similar. Everything follows the same patterns of there is a protocol that your struct conforms to, and then there is a property that you return whatever you need to return. Views, scenes, or in this case, library items. You can see how we have the library example, and it's part of our application, and then it's part of the category controls, which you can specify with this. You can give custom titles, otherwise it tries to find the title from the type of the view, but of course with a B stack it will be very confusing. And then you can just put whatever you want here, and you can just drag it and drop it. You can even drag it on the specific part of your UI that you want. So this is everything that Xcode helps now with SwiftUI. The integration has been amazing. I've just been using it for a week and I already can feel the productivity boost. I had to go back to the previous version of Xcode and I already felt, the restrictions. I just want to start using this for everything, especially with SwiftUI. It's so nice. So now let's take a look at the example application that I built that includes everything that is new on SwiftUI. We're gonna go section by section. The organization of the section, it's fine, but it's a little bit arbitrary at some points. Like I've made the views, then other system integration with the frameworks, then everything about new ways of doing layouts, a bunch of new modifiers that we have, all the new property wrappers, and some other random things. So to do this very nice, we're gonna attach the simulator into the same full screen view. This is probably the most exciting thing that they have done. Finally, you can have the simulator in full screen with Xcode on the side. This is huge. I love it. Even if you are going to use more the previews, this is still a boost. So let's start with the views. What new views we have? First of all, we have a new text editor. This basically, it's very similar to the TextView on iOS. It's a multi-line text editor. You can go here and you can type. It's basically a multi-line text editor like the TextView it's on iOS. Typical SwiftUI API with a binding that updates your local variables, so you can do whatever you want with that. That's very nice. Like again, with the way that SwiftUI it's implemented and the API that it proposes, like when they add these new things, it's very natural to learn them, very natural to use them. Everything it's as you expect with bindings, with you pass the data and it just re-renders itself. It's very nice. The next one, very specifically, it's an Apple sign in with Apple button. So when you do this, it will trigger automatically all the sign-in requests, and when it's completed, you're going to receive callbacks here, so you can integrate it with your model layer. And there are a couple of different styles, but apart from that, it's just the sign-in with Apple button that we have directly now access with SwiftUI. There is also a new menu API, but it's only available on macOS, and I'm not running the new macOS beta, so I cannot show you, but at some point, we're going to probably add it here. So just so you know, if you're already running the beta, you can start playing with that because there is new menus, APIs for that. One of the big things that everybody is loving is the new color picker on iOS, and we of course have it available on SwiftUI. Again, its usage is as expected. You pass a binding to a color. You can specify if you want to support opacity or not, and then the picker itself, visually it looks like this when you put it on a view, and when you click on it, it opens this fancy nice picker that it's shared across the entire operative system. If you run this on macOS, it's going to use the native macOS picker, so that's very nice. And you can even save more colors to keep your palette going. And once that's done, you can have it on your view. There is a bug now that, as you can see, I cannot dismiss view. It's super weird, but it's beta 1, so it's what I expect. What is very nice about this is that the eyedrop, works outside your application. So if you're in an iPad, you are gonna be able to pick colors from a side application. Then that includes, like, you can pick colors from images or other stuff that you have in there. That's super nice, and for color things that you can do on iOS, it's a huge deal. The next view that it's new, it's an activity indicator, a progress view they call it, because it serves as multiple purposes at the same time. So by default, when you have a progress view, it uses the circular progress view style when you don't pass any parameter to it, and it's just an activity indicator. But then you can pass a value that it's binding to a float, and when you do that, it shows this bar here that automatically renders and updates when the value of the float changes. You can pass a total to basically decide what's right. By default, it goes from 0 to 1, but if you want to change what the total means and what the value of the number represents, you can pass the total, and it's going to do the calculations for you automatically. And finally, you can pass content, like, which can be any view, and that's what it's used here at the bottom on this UI. Super nice, it's quite customizable, and it's very nice that you have a progress view finally natively in SwiftUI. But I really like this API that if you don't pass a value, it's treated as an activity indicator, and if you pass a value, you have a progress bar. So here we have the watch simulator displaying this new UI component that we got, and you can see how you can pass a value in there and the range from that value. It's like a progress view from iOS, but specially designed for watchOS, where you can also include different kinds of information. You can put an image, and that's what you should see here in the middle. I've seen that on the sessions, but for some reason it didn't work out for me, maybe just beta 1. But apart from that, you also can specify the current label here, and that's what you see big in the middle of the gauche. And then you have a minimum and a maximum values that are here on the left and on the right, and automatically flip when the language changes and all that nice stuff. To get this, you can have the circular style here, which it's all coming from watchOS. The next one, it's a label. And the label in SwiftUI, it means a text and an image attached to it. It composes these two things together to make them easily to reuse in different parts of your application. And to use it is very nice. You just pass the string on the initializer, and then you can just even pass directly a system image, and it automatically creates the label for you. There are other initializers that allow you to customize specifically what you treat as the image or as the labeling or as the text, and it's very, very customizable. But the whole thing is that it creates one component that pieces both things together. And again, seems like beta 1 has some aligning issues with this, but hopefully it's fixed unless I'm doing something wrong. The next one is an interesting one because it's like a button that automatically opens a URL on the default browser, Safari. And to make it, you just have to specify the string that you want to show to the user and the URL that should open. And indeed, when the user clicks on it, it just opens Safari to that website. This feels interesting, a little weird that we have a specific thing for this, but I guess with the new widgets, the different tappable areas and all that stuff, you may want to have ways for the user to open your application at a specific screen. So maybe this is a nicer addition for that. The next one is the new date picker on iOS. Of course, now by default, it uses the new date style picker, which is a graphical style, which you have the calendar, you have the date here, you can pick the date from this place, you can close it, you can move back and forth, you can pick the dates, you have this time here that you can switch. It's full featured date picker that we have on iOS now, and you have full access to it on SwiftUI. And as before, it just gives back that date on a binding to a date object. Very nice indeed. The next one, it's text. And you may be surprised because text is not new itself, but they have done so many additions that I have to show it here. So first of all, before this version of SwiftUI, you could always interpolate a text in the string, and that just worked, and that was the default behavior. Now you can pass a date directly to text and specify a style that you want to display it. And you can see here how we have the date style, the time style, the offset style, but here you can see the super interesting thing that offset, relative, and timer, they know that they need to update themselves automatically to reflect when the time changes to the user. This is super useful. You don't have to do anything. For example, just using this on a list of cells is going to make sure that the relative time, for example, automatically updates without having to pick the cell or keep the label reference and update it and take care of when they need to be reused. It's a whole mess. It's not easy to do on UIKit. And now we have SwiftUI doing it automatically for us with this initializer. It's super nice. And because you can just interpolate text in text, all of this just works. It's not like you have to have this and work around on your UI. You can still interpolate the rest of the text as you want it. Then we also have a specific initializer for a range of time from start to end, and that's what you see here. And also, if you don't have an end, you can just have an initializer with a date interval, with a start date and a duration, useful for events or something like that, that it represents the same thing but with a different initializer. Another nice addition is that you can have this text case to automatically uppercase or lowercase the text without having to do it on your string. So you can just take from the model your string directly without having to manipulate that, and then your UI is going to take care of showing it as it wants. So this is all new things about styles that have been added on the text. But there is more, because if we take a look at SF symbols, which now supports multicolor symbols, and it's also finally available on macOS, we can take a look at a couple of different things. First of all, we have an SF symbol like before, where we can say the image scale is larger. This is not gonna increase the text point size, but it's gonna make sure that the icon looks bigger but always appropriate with the point size that it's together with. And that is what I wanted to show you. We can now interpolate images directly into the text. This is amazing. So this is making things so easier. In this case, we probably should have been using a label. As you can see here, it's like the same thing, but it's so much nicer that you could interpolate images anywhere on your string, and it's gonna be localized. It's very, very nice. There is so much time wasted on these little things, and it's super nice that SwiftUI tackles these issues directly. And finally here, it's an example so you can see the different styles of rendering that the SF symbols icons have now. We have the default style, which is like rendering mode as a template, and it's just black and white, or takes the theme color of your application if appropriate. And then you can specify directly, on this case, a different color, so we can have full red. But then some of the icons, as I said, they have multicolor support. So if you use rendering mode original, they show the different colors on the icons. This is how, for example, the weather application is having the sun and the clouds and the rain all with different colors. That's because they are using SF symbols, so you can use them too, but they support multicolor rendering now. The next one is an addition that you may not realize, because it just comes as a change on a style, and they do a lot. Like, they use existing views, like for example the TabView in this case, and now they just offer a different style for that same view, and it completely changes the way it visually is. In this case, we have a page style, you can see, pim, with the indicators here, and it's just a tab view with a specific page style. If we remove this line, we're gonna see the typical UI tab view controller from iOS with the tab bar here at the bottom, and you click there and you go to the specific tab. Now this is a way to switch from that tab bar view into this paginated kind of UI. Toolbars are finally something that you can work in SwiftUI directly, and they are very flexible and super nice to use because they respect the standards from the operative system. We can see here just a random view with a text and a button, and now we have this toolbar modifier that lets you add toolbars on the view. The way you do them is with a toolbar item, and they have this interesting property which is called placement, and there is a bunch of constants here that you can use. And for example, the most interesting ones is you can put navigation bar leading and navigation bar trailing, for example. You can put even more than one of the same, and you can see how they stack them automatically here. And the one that we put on the trailing, it goes on the right automatically. But also you can say, okay, put the placement at the bottom bar, and a new bottom bar is created. You don't have to create that view yourself, and it's gonna again just use the native iOS, in this case, toolbar at the bottom, which is a pretty common pattern. They also have these other constants, which is for cancellation actions and confirmation actions, and that works very well when you have a model presentation. For example, with this, you now can have the automatic toolbars of a model to close and confirm it if you want, instead of just relying on the user going back down with a slide, or implementing, like we used to do before, implementing a wrapper view to add these buttons on every model presentation, because there was no way to do it before. So I think I have a post on the blog from the beginning of SwiftUI where I explore this, because it was a real pain in the ass that you just do a model and there is no way to close it automatically. The next one, it's one of these new views that we have, but it's the same view, it's just with a different style. So we can see here how up until now you could take a list and make it a group list style. That was already available. It's the typical group visualization of a table view on iOS. But now we have this new inset group list style, which looks like this, which is available on iOS 14. And it's very nice because this is such a common pattern that it's very nice that finally we have it. It's always been kind of like a pain in the ass to do these things on UIKit, because you need to just do the rounding on the free cell or put a wrapper. It's always been a little painful to do. And now it's just, you just do the group list style and that's it. And finally, to show the sidebar style, which is also new, we should probably go into an iPad. So on iOS 13, you could already use a navigation view with 2 subviews on it, and it will treat it as a main view and as detail view. That's what you could do before, but now you can add a third view, a list, and set it as a list style, sidebar list style, and that makes it use this new fancy sidebar list on an iPad, so you can have 3 column layouts. Ignore this weird thing here, that's because we are pushing it actually from another menu, so it behaves kind of weirdly. That's it for all the new views that we have now available on iOS 14 with SwiftUI. Now let's take a look at other views that have been added by framework. This is when you import that specific framework and SwiftUI at the same time. These new views are available to you. The first one is a video player from AVKit, and you can see how it's just a native video player from iOS. The next thing is that you can have the overlay also created with SwiftUI very easily. Here you have all the powers of SwiftUI, so you can put whatever you want on the overlays, and you can see that we have the native player behavior there. The next one is MapKit. We don't have to wrap MapKit anymore manually to use it in SwiftUI. We now have a map that comes from MapKit itself, and you can see how you can pass a binding for the region, so when the user moves the region, you get updates for that automatically, and you can have different interaction modes, which is like, it basically decides if you can pan the map or actually even zoom it, and they have the different options like show the user location or automatically track the user and all that kind of stuff. And then finally, it's kind of like a list. You pass an array of items, like you can see here. That behavior is like similar to the way the list works. And then you have a closure here, a view builder. You can create an annotation for that specific item. The annotations, they come with 3 different styles. You have the map pin, which is the typical map pin from the original iOS versions. Then we have a map marker, which is like with this new style with more like a rounded silhouette. And then you have the map annotation, which is like you can do whatever you want in there. And it's very nice because, again, we have the whole power of SwiftUI to use here. Here, I'm not even using a view, for example. I'm just using SwiftUI shape APIs to just have a circle with a stroke color and a specific size. And here you have it. Now, we just defined super easily a region of space where the user is, for example. The next 2, you're not going to see an example here, because to be honest, I didn't have the time or the expertise to go and show you a super cool SpriteKit or a SceneKit scene in SwiftUI. But basically it boils down to, now if you import these frameworks, you have a sprite view and a scene view, where you just need to pass the scene from a SpriteKit or the same thing from SceneKit with so much more parameters because it's a 3D space coordinate system. And now we just have that, and then you have it fully integrated on your pure SwiftUI hierarchy. And the next thing that they added, it's an App Store overlay. It works like any other presentation API in SwiftUI. You just have a modifier with a binding to a boolean that tells you when you need to show it or not. And when you click in there, it shows you this nice preview. You can have some customization about the position of it, and then when the user can click in there, if it was a real, like if it was running on a device, for example, with a real app store available, it will just show the user the entire presentation from the app. And that's it for the integration of SwiftUI with other system frameworks. Next one is layouts. Here we have probably the most interesting additions in SwiftUI, something that we have been requesting for the past year, and people wanted something like a collection view in SwiftUI. So we didn't get that. We kind of got something better in some aspects. It's still not as flexible. For example, collection view has a full custom layout that you can use, and that's not what they migrated. What they migrated here is lazy versions of the stack that we already have and a new grid layout that you can also use lazily. Let's explore this thing. The first thing we're going to take a look is at lazy stacks. You can see how we can have a scroll view, and instead of just using a B stack inside, we can now have a lazy B stack. The parameters are the same as before, and the behavior is literally the same as before. You can just have a for each inside, and then you need to show like your rows, like you can see here. The difference is that now this is lazy, so it should behave much more quickly, and it should behave properly in huge amounts of data. And collection view has this all new layout system where you can nest sections with different layouts inside each other, but we can use the same thing here in SwiftUI. You can see how we have an horizontal row, which is another lazy H stack. Now, I've read a little bit on the forums, and I think that developers from the frameworks have said that in this case, I'm not sure if the system loads entirely the horizontal scroll, but it's still not bad. I'm not sure if it's going to be improved at some point, but if that's true, which I'm not 100% sure, it's still not bad because usually on these horizontal scrolls, you don't have much content in it. So yes, collection views is still super cool and super nice, and probably the only thing I miss from UIKit, but SwiftUI, it's getting there every year. Another layout addition on the scroll views that offer these lazy B stacks is that they have a property which you can specify what you want to pin, and you can say, for example, pin the section headers. So when you have a section inside the scroll, you can specify the header like before, but now this header is pinned like we are used to on the table views. So you can actually replicate that behavior out of the box now with this system. And again, you can put any view that you want there super easily with SwiftUI. It's very nice. And here you have the grids. The grids have so many options and they are so complex to explore, but I just took this example from one of the sessions, which you can see how you make a scroll view, and in this case we tell him to scroll horizontally, and then we use a lazy horizontal grid, so the things are flown in and scrollable on the horizontal axis. And then these grids item, they just specify how it works. You can put like a fixed repeating system, or you can have a flexible, so it adapts into the content. If it has a space, it's gonna put more rows or columns than if it has less space. All of that is gone out of the box and super nice. And one thing I note here from the session snippet is that you can see here how we finally have inline variables in the SwiftUI DSL syntax. Again, you can watch my property wrappers latest video, which I'm going super deep into everything new that we can use from property wrappers. And finally, scroll view. Of course, a scroll view, it's not new, but I just had to show it to you because it has what we have been asking and crying for the last year. We can programmatically control the scroll position finally. The way it works is in the same way you have a geometry reader, you now have a scroll view reader. And the scroll view reader is gonna give you this scroll view proxy, which you can call a scroll to move the scroll to a specific position. It automates a lot of this work for you because you're just passing an index, and because the scroll view knows the views that it has inside, it's just gonna scroll the position, for example. And here I just made like a pagination system. You can see that this is a normal scroll, but we can page next and previews, and I'm modifying manually, programmatically the scroll position. Here I just wanted to experiment if we could nest a geometry reader with a scroll view reader, and everything works fine. Like I just used the geometry reader to make these things full width, and it works perfectly fine. And now a couple of other nice and big additions in system layout with SwiftUI on iOS 14. We now have a fully outlined system like you had on macOS. Now we have it on iOS, which of course has been needed and widely requested for pro applications on an iPad. It makes the iPad finally have all these new nice things that macOS had, so like they are closer together than ever before. Here you have like a simulation of file system. I took this from another session, and you can see how we have folders, and we have some folders that are empty, and some have documents and all that stuff, and all of this is done automatically with this SwiftUI new view, which is an outline group. An outline group works very similarly as a list, where you pass the data that you want, and the difference here is that you specify a key path, so the system knows what property need to use to recursively traverse the tree. And then you just, on the closure, on the view builder, you just use the view as you want, so you have full control here of how you want to display each row or each item. The interesting thing is that this outline group, it's built on top of the disclosure group, which we also have available here. The disclosure group, it doesn't have the whole power of a full outline system, but it's super useful when you have parts of your UI that you want to hide and expand, and even including sub items, like all of this works out of the box with this disclosure group. And it's very nice because that's what they use internally on the outline group here. Basically, the outline group recursively uses disclosure groups to render your UI. Very nice, very composable. It shows you how the framework itself uses the same techniques that we are using. So that's for the new layouts that we have. But that's not all, because we have modifiers. The first modifier that we have is the isPlaceholder true, but that's not yet available on beta 1. What I can show you is what it does and how it looks. We can just attach this placeholder into any view, and SwiftUI automatically makes a version of the view that looks like a placeholder, so without real content, and it replaces where the text goes with these rectangles and with background colors of just shapes. This is very nice, and it's of course obviously implemented for the new widgets, because when you are adding a new widget, you have this fancy nice gallery, and all of this is used with placeholders. So you can, if your data is not available yet, or you don't want to show real data here, you can use this isPlaceholder modifier. The nice thing about it is that you can say to specific views to not be placeholdered. For example, in this example from the session, if you wanted this panda icon to still be visible, you can go to that image and say isPlaceholder false, and SwiftUI is going to keep that image as it is, like the real version of it, and everything else is going to be placeholder. It's obviously for WidgetKit, but it looks like it's going to be available on the entirety of SwiftUI for any platform, not just for widgets. For the next modifier, we also need to look at the widget API, because it's specifically done to solve a problem for the widgets, but you can use everywhere else on the system where you also have these issues. On the widgets, you can see how the widgets have this rounded corner on themselves, which means that when you have a view with a background inside, you also want it to be around the corner, because that's part of the iOS design. The problem is to know how much rounded this corner needs to be. You don't really know. You could spend a lot of time tweaking the values and see if it matches or not, but what if the system changes, or in other contexts, if you reuse this on macOS, for example, maybe the rounded corners are different, whatever it is. You don't have to worry about that anymore, because they have this new relative shape, container relative shape, that adapts itself into the closest container that it has, and it takes properties like the corner radius from it. This means that just by using this shape and filling it with the background color that you want, you automatically have the corners of the container of the widget applied into your view. And it automatically updates if for some reason they changed on the fly. It will automatically update for you. They actually correct if you use some insets. They actually correct so it's visually appealing, even if the corner radius doesn't match exactly. They change it to make it visually appealing, it's not mathematically exactly the same. Very nice API, and it makes this whole new widget system very well thought. The next modifier, it's literally mind-blowing. It does something so complex so much easier that it's amazing. So here we have a SwiftUI view with some text, and we are gonna present kind of like a fake model presentation with another view with different content, and what we want is to move this text from here, transition it into the other one. As you can see, it's amazing. It transitions one view into another view from the hierarchy, whatever it is, just by adding these couple of lines. On the source one, you say match geometry effect and you give it an ID, and you use this new namespace property wrapper that creates kind of an identifier of the view that you are working with, and it's managed by SwiftUI, so even if the views are recreated, it knows that that namespace corresponds to that view all the time. And this lets you make sure that the identifiers are not mixing with each other. And then you use the same match geometry effect in the other view that you want, and that's it. Nothing else. SwiftUI takes care of the animation, the transition, it takes care of everything. If you go fully custom, there is a protocol and a struct that you can create to customize with properties from the geometry are actually interpolated between one and the other. The next modifier, it was like an obvious addition. In the previous version of SwiftUI, we had the model sheet presentation from UIKit, typical model sheet presentation, and now we added this full cover presentation, which is just the same thing, but it takes care of fooling the entire screen. Now, the next section is about events. A lot of things that you can do with events on your views. Previously, on SwiftUI, we had this onReceive modifier that lets you observe a publisher and run anything that you want on disclosure when the publisher emits something. For example, I have a timer hooked into it, and when I click start, every second, disclosure is run, and I can do whatever I want there. And of course, when I stopped it, it just stops. Now, this year, they have added another modifier called onChange, where you can pass a state variable. This is because a state variables, since SwiftUI takes care of basically owns that property storage, things like the Swift did set don't work anymore. That syntax doesn't work, it doesn't behave properly. Now we have this onChange modifier where you can pass this state, and when this state changes, you can react to it. So it's like a did set directly as a modifier, and you can see how it just works. But they didn't stop there. They added more modifiers like on OpenURL and on continue user activity that lets you hook into system events, like when your app is open with a URL or with a continuation from a user activity, and react to them. This is recommended for what I've seen, and it makes sense to do this at the scene level, but for what I see, nothing stops you to put this nested on your views, so maybe this uncovers some nice patterns with views are reusable and they take about their functionality themselves. So that's it for the new modifiers that we have on SwiftUI. Let's jump into the big section of property wrappers. The first one is ScaledMetric, and is one that I'm quite excited about. SwiftUI now lets you use scaling fonts with the system typography, but also with your custom fonts. But they didn't stop only there, like that's something they add into a text as a modifier, but they didn't stop there. They actually added a property wrapper that you can use to scale any value that you want. For example, here we have spacing. You can see how I have a spacing of 10 that I'm using everywhere. It's this spacing of 10. And I have this view, which I call scale view, which is these two first ones. And because I'm using the property wrapper, when on the second one, the size category changes to an extra large, the spacing increases too, to make it visually appealing. You can use this for spacing, for padding, for anything that you want. You can just drop this ScaledMetric into your numbers, and it will automatically scale with the text. To compare it, I have another view here that doesn't use the property wrapper, and everything else is exactly the same, and even it's using this extra huge large font, as you can see here, but the spacing, it doesn't increase. And you can see how it doesn't look the same. Maybe you prefer one, the other, depending on the scenario, but the functionality is there for you to use. The next property wrapper, it's all about state management, and it's a little hard to visualize in an example, but I think what I'm gonna show you, it will make sense. So up until now, we had state, of course, for local things, like local state from a view, like I want to know if this toggle is on or off, and I can use it to change my view. That's fine. But then we had the observed object that let you have observable objects, that which your custom view models or whatever you wanted to use, and hook that into your UI, and when they change some properties in them, your UI will be updated. The question has always been, who owns this? You could use something like this, where you could automatically create the model directly on the property declaration, but that's problematic because observedObject from SwiftUI perspective, what it does is observe the changes on the model, but it doesn't control its storage. It doesn't control its life cycle. This means that when this view gets recreated for some reason, this observedObject, it's not part of SwiftUI storage system, and it's just gonna be recreated again. And you can see it here, how we can change the value stored on this observedObject, but as soon as we do something that has to re-render or recreate the views, we lost it. The solution for this is to move this up. If you move this creation of your state up into another layer that doesn't change, that it's the proper behavior that we have been using for this past year. That means that you will have to create your object here and just keep it in this layer, because this screen doesn't get recreated unless you go back and forth, and then yes, then you lose it. That's fine. But at least when something happens on this recreation of this view, this state wouldn't go away. But that's a pain in the ass, because you need to always ask who needs to own this, you need to change your APIs and stuff like that. New this year, we have the StateObject. The StateObject gives us a solution for that. It's very similar to the observedObject, but the difference is that now SwiftUI takes care of its storage and lifecycle. So you can just create it here, and as you can see, when we modify it and the screen gets rendered, this struct gets recreated completely. SwiftUI keeps it alive because it knows that this view, it's not a new view, it's the same view, and it knows that it needs to keep this state alive for you. And that's it. This is super useful. In terms of architecture, it makes it easier to manage the state. This is one very nice addition, and we're going to be using a lot if you use the state management system of SwiftUI for sure. The next property wrapper is this namespace, but there is not much to show. It's used for the geometry effect. As I said, it creates a namespace that SwiftUI knows how to keep for your view all the time, even if it's recreated. And it's also used for focus management on tvOS. So we have two uses of the same property wrapper on the system this year. Probably they're going to expand it on the year because it seems like a very useful API that it works for many different cases. And the next section is about storage. This example shows you how the new storage property wrappers work. We have scene storage and app storage. Both of these property wrappers behave very similarly in that you just give them a key and they take care of storing these properties values and restoring them from a persistent storage, which is NS user defaults. It's the user defaults of the user on the device. So this is not to save all your data, like this is not your data model. This is basically to store configuration or things that your UI wants to recover from in a later point in time. It's very nice for these small values that you just want to save. You can save bigger things if you want, but that's not for what this is intended. Now, we need to jump into an iPad to show the difference between app storage and scene storage. App storage is basically what it says. It's a storage for your application. It's like if you are saving things into user defaults and restoring them automatically. That's just how it works. Scene storage is a little differently. So let me show you. We have here this application running on an iPad, and we have the scene value and the app value. We can change the app value to 20, for example, and the scene value to -10. Now, if we open the app switcher and we go to another scene from the same application, we can see how if we go to the storage, we can see how app it's 20, so it's actually keeping around, it's the same value across any scene on your application, but scene it's a completely different value only for this scene. So we have 11 here, and we have 25, and if we jump into the other scene, we see how the app has changed and the scene hasn't. So the scene storage, it's kept independently for every scene on your application, and the app storage, it's kept the same for all your application. And both of these things are stored persistently on your device. You can see how the initial value was 1, and you didn't see that 1 because I've been playing with it before. It recovered that state from the user defaults. And the last property wrapper that we have, we need to come back here to show you how this works. As we can see, like, this is the only thing you need to make to create an application now, but we have this UIApplicationDelegateAdaptor, where you can pass a class that needs to be instantiated and needs to implement the UI application delegate. This is basically a way to integrate this new SwiftUI model of applications with the old delegate system from iOS and macOS with the app delegate. Here you are just back on UIKit LAN and you implement your UI application delegate. It just lets you do what you were using before, the same thing. It's just that this line lets the system knows that this is the app delegate that should be calling it. If you don't put this line, you don't have to implement anything. The app implementation already has its internal application delegate to create the views and all the windows and all that stuff. So that's what you do with all this new window group and scenes and all this API. But if you still want to know, for example, when you receive notifications and kind of stuff like that, you need to use the old UI application delegate because that's still not migrated into SwiftUI. If you were doing things like user activities and URLs, we have seen that they added event handlers for that, but not for everything. So you still need access to the old delegate patterns. And since I am here, it's a good opportunity to show you another functionality that has been added for macOS and iPadOS about the commands. You can have this command modifier on a scene, and you can create custom commands that do things with even keyboard shortcuts. On macOS, this is going to show on the macOS status bar, and on the iPad, this is going to be displayed as the on the shortcuts menu, so people can, with keyboards, can trigger this shortcut, these commands via shortcuts. It's super nice that we have all these powerful pro systems directly accessible from SwiftUI. Another modifier that has been added that it's mainly for macOS, it's the help modifier. With this modifier, you can specify a text that shows on the context menu when you hover over a button or some piece of UI, like this, that it says library. This was not possible to do before on SwiftUI directly, and now we have this help that allows you to do that. On iOS though, you can see that it's compiling fine even if I'm targeting iOS. We don't see this behavior, that idiom doesn't exist on iOS, but this is also useful to help with accessibility. This text is going to be used for the accessibility system to improve the descriptions that it shows to the user. So it's always nice to have. And another thing that has been added, which I just put here in other, is that we have a new object in the environment, which is to be able to export files from your application. So you're supposed to click here and you see, for example, the share sheet. Using this environment, now you have this export object, which is export files action. It's using the new Swift callable syntax to just be able to call this directly, but you can see that it's actually an object with the call as function implemented. And here you should pass the path to the file, and then you get a closure with the results if that sharing was successful or not. It is very nice to see how these old APIs that were landed in UIKit or AppKit are migrating slowly to SwiftUI to allow us to do everything that we need from SwiftUI. It's clearly the UI framework of the future on Apple platforms, and it's nice that they keep adding these functionalities to it. So that's everything that I found that has been added into SwiftUI. I don't think I've missed anything. Maybe there is something on the new APIs that I haven't seen, but trust me, I've spent a lot of time going through every single detail, and I've waited until the end of the week to see all the sessions that were kind of related to UI to see if there was some pearls in there that we could miss from just looking at the docs. So as you can see, there is a lot of things that we are going to enjoy a lot this year, especially the new grids system, the new property wrappers, the whole way of creating a full application directly in SwiftUI. That's super nice. Again, this is still beta 1, so changes and improvements can happen after I release this video. If you know something that it's not here, I remember that you can make a PR into the repository that is linked below, and that's it for today. If you learned something, which I hope you did because I spent a lot of time with this video, please like the video to show me that appreciation, and subscribe for more content about Swift, SwiftUI, and all random stuff. Thank you very much for watching, and see you next time.